initially will ask us to set the main running time, like the main pump, how much hours or how many hours is it supposed to run. So I'll put like 6 hours, press enter, and then I go for the auxiliary. I put like 3 hours. So this pump will be resting for only 3 hours, then it comes back. I press enter, and then I can start my system. And when I start my system, immediately you can see the main pump is running and the water is going to be flowing to the system. Then you can see the indicator over here is showing you like the pump is running, the main pump is running. It's not in the stop, and the auxiliary pump is in the stop condition. So currently, I'm not going to wait for 1 hour, for 6 hours in this kind of an experiment. But if we waited for an hour, 2 hours, it was going to be showing here because we are just waiting for that hour, an hour to pass, and we see this. But right now, I can forcefully change the variable here. Let me make it like 5. Let's assume there are 5 hours. All right. Let's assume there are 5 hours. If there are 5 hours, you can see the main has run for 5 hours. But now, since 5 hours are still less than the set time, still it has to be on. But if we make it 6 hours, if we make it 6 hours, I place okay, I come back. In 6 hours, you see the 6 hours, this one has to go to rest now, and this pump comes in automatically. When this pump comes in automatically, you see it clears off the data that was in the first, like how many hours it has to come to zero. So as the next time, we shall start from zero as well. And then you can see here the most interesting thing, this one went off and then it shows that it is no longer in running position, it is in stop position, and then the auxiliary pump has kicked in to continue the supply. So in this kind of a system is when we want to achieve like constant water supply and you have like 2 or 3 machines. Yes, welcome to yet another video, and we are still continuing practicing with PLCs. So apparently today we are going to work with a system, let's say, which is designed by major companies like for water supplies or companies that work with water and any, let's say, Coca-Cola, Fanta, whatever. So in this kind of a system is where we find like we have a constant water supply requirement, and you have to have like a pump. Remember, a pump is not going to work for 24 hours continuously. Sometimes you need it to rest, and so we have like the main pump and then the auxiliary pump. So the main pump runs for some time, and then based on maybe your designing or your requirement, let's say for like 5 hours, you have to interchange, and then this one goes off and this one comes in to kick. But we want this flow to this process to be continuous. So to achieve this, you can use a relays if it is the only system you have. You don't have to invest in the PLC because it may be quite expensive. But if I mean you have a larger system and you have other things to incorporate with sensors and whatever, then the PLC is the only way to go. So here, if you have to use the PLC on this kind of a system, these are the connections. This is the PLC side where you're going to be having like the input and output module card, or if it is a compact PLC like the one I have here, it always has the input and the output. So from the input side, we shall only have one button, that is for the start, and then we are going to be having 2 outputs. But for my system, I designed 4 outputs. So one is the motor indicator, I mean the motor itself, the main pump, and then its indicator that will be showing if the pump is on and off. And then also I have 2 outputs, one output going to the pump itself, the auxiliary pump, and then its indicator. So I can say here we have one indicator 1 and then indicator 2. So on the output side over here as well, this is the X0, that's for the input, and then this is Y0, that's for the output going to the motor 1. So this output, whenever we have a PLC, the output does not immediately go to the contactor of the motor, because the contactor of the motor is rated differently, and again as well it's really required sometimes to separate those circuits. Like, you have the primary, the control circuit, and then the active circuit, the power circuit. So in that, you have this output from the PLC coming to the relay. Here, like here, I have the relay board. All this will be DC. So if this output is coming from the PLC, it goes to the relay, and from the relay we can switch on and off the contactor that is going to be contacting to the motor. So this is how the entire system is going to be working. Then from here you can also have Y1 going to indicator 1, and then Y4 going to indicator 2, to be showing the pump is running or it is not running. And then on the HMI, I have included some other positions where we are going to be having the setting time. You have to set the time for the pump. This pump is going to run for how many hours, and this one is going to run for how many hours. And then again, we have the displays for how long is the pump running. Like if it runs for 1 hour, you shall be seeing it is running for 1 hour, it has run for 2 hours, it has run for 3 hours. So as well as set the number of hours, let's say 5 here, 3 hours here. It depends on the capacity of the pump. Which pump is bigger, which pump gives much more volume. They can all have the same flow rate at a particular, let's say, head, but then the rating, if one machine is more bigger than the other, or one machine runs at a higher efficiency, or the comparison can be, if I have an old machine and a new machine, that means I have to consider to run a new machine more than the old machine because of the efficiency and again the power consumption. So you put all that in consideration to decide which pump is going to be running for more as compared to the other. As of that, that being said, I can help you to see how I did the program and then run the simulation. Thank you. So in this video, and this is the kind of the HMI that I was telling you, whereby we are going to be having the main pump and the auxiliary pump. So in here, the main pump is going to be running for any hours you set, and then the auxiliary pump will come in to just help this pump to be at rest. So whenever the client is given this kind of a system, they will be only seeing this kind of a screen, and they will have to interact with the screen. So the client himself will just always come here, and then we'll put in the time for this pump to run, and then the time for this pump to run. So let's say he wants this pump to run for 5 hours or 7 hours, and then he wants this to run for 3. This is the setting area. It collects the input. And then this one is going to be displaying how many hours like this pump has run and this pump has run. We only have one start and stop. So it is a maintain button that when you press it, it was going to start the system, and when uh, release it, it's going to stop the system. And these are the two indicators we talked about. So coming in here a bit, we can see our program. Our program, we have only one input, and then we have 4 outputs. That's the main pump, and then the main indicator, then the reserve pump, and then the reserve indicator. And then we have a lot of memory dedicated slots where we have, well, remember we said you're going to store some variables. You're going to store some value in the for the start, for the main pump, and then store some value for the auxiliary pump. Then as well, the running time and then the running time of the auxiliary are going to be stored in some register. So these are the dedicated ones. So as you can see, over here we will dive into our program. So this is how the program has been designed. Let me just maximize it, zoom it in, and then make it a little bit bigger. So in this our program, we can see we have a few ladders that are going to be driving this system. And then the first ladder is going to turn on the main pump. So I just want the main pump when it is on, and as well the indicator has to be on. Then the start button has to be closed. And this when this start button is closed, it is going to be meeting this internal relay, and it is going to be in the normally closed condition. I'm going to explain this later on. You understand why I put this to be interlocking with this. Then we have this our command. This our command is going to be helping us to count the hours. Like if you put 5 hours, this our command is going to raise a signal over here because it has two inputs. It has the time you set, that is in D01, because in D01 we are going to store the time you set. And then in D1 it is going to be like if 1 hour passes, we are going to find here 1, 2 hours, we are going to find there 2. But when this one meets this, like if you put 7 and here there is 7, this signal will go high. So whenever this signal goes high, we want it to go to the main to one of our internal relays. So this one is set high. So what do you understand by this? If this one is set high, definitely I want my reserve pump to go on. So if my start is on, and then I have this in again, this is the complement of this, then my reserve pump is supposed to be on. Yeah, my reserve pump is supposed to be on, my reserve indicator is supposed to be on. Then as well, I also have its hours to run. So the hours for it to run there in D3, and then the runtime is going to be displayed here as well. Then here we are going to be having M2 being set up. But now we have to see how we are going to use M1 and M0. So whenever M1 is set up, we want this one to go on. We want this reserve pump to go on. So I will have to put a logic to put on my M1. So my M1, remember my M1 is when automatically I press this, is going to be on, but now I have to switch it off when this signal goes high. So when M1 goes high, when this M1 goes high, it's over here, it has to set M0. And when M0 is set, this one is going to be high, and then our reserve pump can go on. And whenever you make this system, make this contactor high, that means it's normally open. This normal close is going to be normally open. Now, this one is de-energized and the main pump goes off. That's how now you're going to understand why we had put this M0 here, M0 and M0 here in complementing. So whenever this one goes high, M1 goes high, I have to set this, and when I set this, this one will be fired, and then I can have this one on. And then when it goes high, I want to release the data that has been stored here, the runtime, and as well as also I release this signal because now I want in the next running this signal to be down. So I set M0, I reset M1, and again I reset D1. Yeah, so I have released everything, every variables that have been stored. And then whenever M2 goes high, I need this pump to go off. I need this pump to go off. And then I need this pump to go on. So the main pump will go on. So it's logic. When this one goes high, of course, definitely I have to reset this. So as in the next coming iteration, it won't be high. Then I have to reset D4, this one. I have to clear every data that has been there. And then I reset M0. And remember, when I reset M0, this one is going to be de-energized and the pump will go off here. And this one is going to be de-energized, and that means it can complete the circuit as well. And then this pump goes back on. So we have to run this. It's already compiled. And then I decide I choose to run it. Or I have to put on this the driver. So I have to run the PLC because already the program has been is already downloaded in the PLC. Then I go online. Okay, let's first download the program in the PLC. It's getting there. Then we are online, and then we put the communication on. Once the communication is on, Uh, what else? We have to go to our HMI here, and then when I'm in my HMI, I can go to the project as well. I compile it. I believe it's all successful, and then I go for offline simulation. Yes. So right now you can see here. What we have here, we have our system is just all that. There's nothing that has happened with it. And then this system initially will ask us to set the main running time, like the main pump, how much hours or how many hours it's supposed to run. So I'll put like 6 hours, press enter, and then I go for the auxiliary. I put like 3 hours. So this pump will be resting for only 3 hours, then it comes back. I press enter, and then I can start my system. And when I start my system, immediately you can see the main pump is running and the water is going to be flowing to the system. Then you can see the indicator over here is showing you like the pump is running, the main pump is running. It's not in the stop, and the auxiliary pump is in the stop condition. So currently, I'm not going to wait for 1 hour, for 6 hours in this kind of an experiment. But if we waited for an hour, 2 hours, it was going to be showing here because we are just waiting for that hour, an hour to pass, and we see this. But right now, I can forcefully change the variable here. Let me make it like 5. Let's assume there are 5 hours. All right. Let's assume there are 5 hours. If there are 5 hours, you can see the main has run for 5 hours. But now, since 5 hours are still less than the set time, still it has to be on. But if we make it 6 hours, if we make it 6 hours, I press OK, I come back. In 6 hours, you see the 6 hours, this one has to go to rest now, and this pump comes in automatically. When this pump comes in automatically, you see it clears off the data that was in the first, like how many hours it has to come to zero. So as the next time, we shall start from zero as well. And then you can see here the most interesting thing, this one went off and then it shows that it is no longer in running position, it is in stop position, and then the auxiliary pump has kicked in to continue the supply. So in this kind of a system is when we want to achieve like constant water supply, and you have like 2 or 3 machines, because I mean like a machine running for 5 hours and above is gonna be having a lot of heatings, you start incurring a lot of losses and also reducing its life cycle. And so you can see this machine is supposed to run for around 3 hours, but we are not going to wait for the 3 hours. Let's change and we make it 3 hours. Assume 3 hours have passed. I change the preset value over here. uh, so let's assume 3 hours have passed. What is happening? After the 3 hours, this pump, the main pump comes back. This one is indicating the auxiliary pump is off. Nothing is happening on this lower side, but this one is now kicking in, and continuously we are having our supply. So the system is working perfectly. It can be dispatched. You can be confident enough to say, I have designed for you a system. Now you can go. This is a simple SCADA that you can do for these systems. So thank you. We'll meet in the next video.